As we saw in the last video, memory models are helpful for monitoring what goes on in our programs. It's time to take this concept to another level and learn how to draw memory models using reference types. A primitive type is the most basic data type. These types store simple values. There are 8 primitive data types. Each type uses a fixed size block of memory that holds a value associated with a variable of that type. It's important to note that each primitive type has a range of maximum and minimum values it can hold. In contrast, a reference data type does not store values. Using the new operator instantiates a class by allocating memory for a new object. A variable stores a reference to where the object resides in memory rather than the actual data itself. To help you get a better insight of how references work in memory models, I'm going to relate references to houses in a metaphor. The blueprint to build a house is like the class in Java. Using this blueprint, you can build as many houses as you want. Each house you build is like instantiating a new object of that class. And each house also has an address, of course. And if you want to tell someone where the house is located, you give them a card with the address written on it. That card that has the address written on it is like the object's reference. So if you want to visit the house, you go to the address. I know, that was a lot to take in, so why don't you take a moment to pause the video and digest how the housing metaphor relates to references. Okay, welcome back. I think we're ready to work through an example of a memory model using objects. Get out a pencil and paper and we can trace through this code together. So, this is the code that we will be working with. We'll keep the code up here to give us some extra workspace. So, this first line creates an instance of the class world. Remember our housing example? The class world gives us a blueprint to create a world object. Specifically, the world blueprint instructs us that a world object has 2 characteristics, one being the width of the world and the other being the height of the world. I'll set up my grid in increments of 20s, but you can set up your grid however you want. Lines 2 to 4 declare 3 turtle variables. Remember how we talked about the difference between primitive and reference data types? It's important to note that when we are declaring a reference data type, which in this case is the class turtle, the value of the variable is not determined until an object is actually created and its reference is assigned to the variable. Declaring a variable does not create an object. So for now, we can just write out the names of the 3 variables and draw squares next to them as a way of representing that they may perhaps store data. But in line 5, this new operator actually instantiates the turtle class and allocates memory for a turtle object, which if you remember in our housing metaphor was the house. The reference to where this object is created is stored in the variable Michael. Remember in our housing metaphor, the reference is the card that has the address of the house written on it, not the address itself. So Michael stores the reference that holds the address to this green turtle. The reference is represented by this arrow. This green turtle object is created at the coordinates 50, 50 in the world our home. So let's place it on our grid. So same concept here in line 6. Why don't you take a moment on your own to draw out the memory model that will include this object and where the object will be on this grid. Cool. This is what you should have drawn out. The variable alley stores the reference of the object created at the coordinates 25, 75 in the world our home. This turtle object will be purple. Let's move on. In line 7, the turtle object that Michael points to will move forward 10 spaces. That's this green turtle object right here. And now, the turtle object that Ali points to will also move forward 10 spaces. And that should be right here. So now comes all the crazy reassignment. In line 9, the variable Kobe, who was not referencing any turtle object, is now assigned to reference the object that Michael currently points to, which is this green turtle right here. However, in the next line, Michael now gets assigned to reference the object that Ali currently points to, which is this purple turtle right here. Note that here, variable Kobe and Michael now reference two different turtle objects. This means that whenever we call the variable Michael, it will invoke this purple turtle object, since that is the reference that the variable Michael currently holds. It will no longer move the green turtle that the variable Michael once held its reference to. So, in line 11, why don't you take a moment and determine how the memory model will look like now? Okay, so the variable Ali now references the same turtle that Kobe currently references. This means that the variable Ali and Kobe will both point to this green turtle. So Michael turns right and then moves forward 20 spaces. Since Michael holds the reference to this purple turtle, this object will move. Okay, now in line 14, it seems like the code wants to instantiate a new turtle object at the point 7525, and the variable Michael will now hold the reference to the new red turtle. In the line 15, Kobe moves forward 10 spaces. Then Ali turns left and moves forward 20 spaces. Which turtle does Ali point to according to our memory model? The green turtle, which is the same turtle that just moved in line 15. And finally, the variable Michael, who holds the reference to this freshly instantiated red turtle object, moves forward 10 spaces. And we're done! You drew your first memory model using reference data types. These are the shapes that the turtles have drawn out, and these are the variables with their current references. Feel free to review over the material we covered in this video and trace through the code on your own. Then you can check it against the solution we came up with.